This is Bayesian in R. So if you want to learn business analysis and how to apply Bayesian to business problems, you were in the right place, my friend. You were going to learn a lot. In fact, you're going to learn one secret today that can save your organization $1 million or more. How fantastic is that? We're going to be featuring Bayesian and BRMS today in the code. All right, so let's kick this thing off. Agenda for today, guys. We're going to first cover why you should listen to me. Second, we're going to cover a business problem. And this is a specific problem. It's about an experiment that I put it together. It's called a customer offer experiment. Third, we are going to give you a secret. This is the one secret that you can instantly implement today. All right. Then we're going to go over the how. How do you implement that secret? And I'm going to give you a full tutorial, which is going to be 300 lines of code. How fantastic is that? Fifth, we're going to go through some conclusions, and I'm going to show you specifically how to take what you learned today and how you can save a company $1 million using this secret. And you guys are going to get a free gift for everyone who sticks around to the end. That free gift is amazing. Here's what it is. So you're making an investment in me and into your education today. So you got to stay to the end and you're going to get this gift. It's a $97 value. It's the ultimate R cheat sheet. And what this thing does is it consolidates the entire R ecosystem of 20,000 R packages on CRAN into the 100 best. So this is like the cream of the crop, guys. And this saves you years of trying to figure out what to focus on. It breaks learning R packages down by category. And so if you're learning things like text analysis, deployment, big data, machine learning, finance, when you want to work in these fields, these are the packages that you need to learn. You will get this at the end of the presentation, so stick with me, guys. All right, we've got some new people. It would be a disservice if I did not properly introduce myself. So hello, I'm Matt. Nice to meet you. And I have a confession. I used to have a confidence problem. No, it's not the confidence problem that you're probably thinking. It's a different type of confidence problem. Nowadays, I'm really confident because I know my model's risk. You see, here's my confidence story. I used to work at a company called Bonnie Forge. This is their website. And what they do is they provide machinery into oil and gas applications. And so I had a big problem because this happened. So this yellow region here is my time at Bonnie Forge, and this is the price of oil. So we can see it's going up and up and up, and it gets to about $100 a barrel back in 2014. And then it falls off a cliff, going from 100 to at the beginning of 2016 to about $25 a barrel. Okay. So this led to record layoffs, lower workloads, and even lower revenue. All right, guys. That's when I decided to reverse engineer things that I was learning from Kaggle winners and what they were doing. So I was doing a lot of research at the time. So in 2014, there was a time series competition that was sponsored by a company called Walmart. And I learned from this competition. So while this was happening to the oil prices, my department went from making about $3 million per year to $15 million per year. Now, here's the secret, guys. This was all secretly powered by R. All right. So by the end of 2016, I was, number one, reporting directly to the CEO. Number two, I was making $150,000 per year. And number three, it wasn't all up and up. So this brings me to my confidence problem. You see, after I had gotten promoted, I then started to try and stack on wins, which is the key number one way to advance your career even further. So I came up with the idea for this program called Fast Track, and it was based on needs that I was seeing and analyzing gaps in our business. So I presented this to my CEO, and he loved the idea. He loved it. He loved it. And within a month, I had buy-in from the executive leadership for a $6 million project investment into this Fast Track program. You see, we had to build a whole new line in our production facility to be able to support this fast track, quick turnaround program. Now, this investment was largely based on a model that predicted $2 million in revenue in the first year from the United States. So here's what happened. I predicted $2 million revenue for the US as part of this model that I had created. But after 12 months, we had only made 7% of my prediction. You see, I was a little bit too confident in this estimate here, right? So I thought for sure my career was pretty much over, and I couldn't afford it. My family was growing at the time, so I could not afford to get fired. Yes, this is my beautiful wife and my 2 children, but there's some good news. There's a silver lining, my friends. My model wasn't all that bad, because I didn't just predict for the US. I actually predicted $5 million from Europe based on a more mature market over there. And they did it. They did, in fact, $6 million, which crushed it. All right. So I learned 3 things that day. Number 1, modeling new products is tough. Number 2, I needed to truly know the confidence and risk in my models. And then number 3, I needed to teach others what I was learning. You see, I had a sneaking suspicion that other companies were having a tough time with this as well. And with my newfound skills, I began to get into training. You see, what I was able to do was add an extra $100,000 per year into my pocket, training elite data science teams like the ones that you guys are seeing right here, S&P Global. In fact, this is me at one of their workshops, and I got paid to travel, to train, and to learn. These are my real passions, guys. So you can see a picture here. This is my daughter back before COVID, and we're flying to one of my trainings. And I've got my favorite book right here, Applied Predictive Modeling by Max Kuhn. Get your copy today, guys. I love that book. All right, but today isn't about me. It's about you. You see, today, what I want to do with you and what I'm going to do with you is to teach you one thing, not 1,000, but one thing that you can implement that will help you understand your model's risk, and it can make your company $1 million. All right. Does that sound fair to everybody? Put it in the chat. You guys okay with me doing that? Does that sound cool? All right. Who wants to learn this new skill? Put it in the chat. Oh, I'm seeing lots of yeses here. Okay. All right. Well, let's do it. Now, here's the thing. We can't just jump into the skill without knowing the business problem first. You see, I have to give you some context, right? Otherwise, you aren't going to know how to implement this skill. And my goal today is to leave you here with everything you need to be able to actually implement this thing. So let's talk about the business problem. This is called customer offer modeling, and we're going to do it using Bayesian confidence. I'll explain what that means. So don't worry, if you're a beginner, I'll explain. You see, the problem with models isn't their prediction. And this is where everyone gets confused. This is a big mistake. The problem is it's how confident you are in the ability of your model to hit the mark. Okay, so let's digest it. And to make this crystal clear, I've got an example for you. You see, let's say we have a customer. Okay, we've got a happy customer over here. And what we want to do is we want to send them an offer, at least make an experiment, send a test and give them an offer and say, you know, hey, we've got a nice shoe. We know you love shoes. This is normally priced at $110, but today only, we're going to give it to you for $89. Okay, this is what we call an offer. So you're going to do something special for that customer. But the key question here is, would that customer have bought it for $110? So you go through this process of building an experiment and developing a model. And then your model predicts something. It actually, in fact, predicts that customer will make 4 orders over a 12-week period versus an estimated 1 order without seeing that offer. Okay? So if everyone is following me there is a big problem with this assumption. Okay? The problem is how confident are you in that model's ability to predict that that customer will actually, in fact, buy for? Because all models are wrong, but some are useful, okay? Enter Bayesian confidence and the thing called the credible interval. So we're going to focus on that key aspect. So if you've never heard of Bayesian before, Bayesian is really cool. It does basically what every other modeling algorithm does out there, which is fit a line to a series of data. Okay, so look at this white line. We call this the model fit, right? You see this white line. Does everybody see that? You guys see what that white line looks like and how it follows that data? Okay, but here's the cool thing about Bayesian is it doesn't just predict that line, but what it actually does is assigns a probability to every key part of this entire trend, okay? And we call this the credible interval. So you can see the blue region is like 66% of your data is projected to fall in there. And then the light blue region is 95%. And you can see only a few data points fall outside. But here's the key, guys. I want you to see this. So as your data's, and we call this spread or variance, as it varies more, those intervals get wider. And that's what every other type of algorithm does not do. So we're talking a probabilistic measurement here, or a probabilistic prediction. And you can see as that dispersion gets less and less, those bands get tighter and tighter. So you actually can characterize the risk in your data much better using this modeling technique. Okay, so how does Bayesian come up with this credible interval? That's the next key question. It uses a technique called Markov chain Monte Carlo, and you can see what it's actually doing is coming up with distributions, and it's actually doing what's called sampling. So we're going to do like 4,000 samples of this data set, and we're going to iteratively calculate these measures for these key parameters, and then it's going to put that into a model for us. Pretty fantastic, right? So this is the key part, though. If you take one thing away from this section, this is what it allows us to do. Crazy things like actually understand our model risk. Remember, we want to know how risky our decisions are. We just want to know this point forecast, but we want to know the probability. All right. Does that make sense, everybody? Let me know in the chat. Does that make sense, everybody? Okay. All right. You guys are following me. All right. Who's ready for a demo then? You guys all ready for a demo? All right. Absolutely. Okay. You see, guys, we have 300 lines of code to get through. All right. That's a tall order. So get ready because I'm going to be doing this very fast. So what I need for you guys to do is get ready and get your notepads out, get your screen recording software, your snapshot tools, whatever you need, because we're going to be flying through this. All right. I am not wasting time here because we have 300 lines of code and I got to get through it quick. All right. There's your warning, guys. Let's do our 30-minute demo. This is how to save your company $1 million. All right. For my LL Pro members, you guys are going to be getting a full suite of data, models, and a key analysis here. And we're going to give you a bonus, a nonlinear example that I was putting together for the tutorial. And we're actually going to expand on this example in the next series, in the series of Bayesian, because we're going to talk about GAMs. But let's not worry about this. This is just the introduction. Okay. So we're primarily going to be working out of this file here. It's this O1 customer offer experiment file. Now, full disclosure, we have a data set that we're going to be pulling in here. That's our customer offer data. More about that in a minute. And we have two models that I've pre-built, a basic Bayesian model and also a mixed effects model. And I'll explain what that means later. But just for now, just keep in mind, I have two models. The reason I did that was because these models actually take quite a bit of time to run. I'll try and run the first one, but I don't want to spend a whole lot of time running models, so I saved them in advance. All right, next thing to go over. All right, we've got the outline here. So this is my outline. We're going to be flying through it now. So this is LearnLab 74, Bayesian for Business. A little bit about this. We're going to be analyzing the effect of two offers on customers. We're going to be using Bayesian Poisson regression. I'll explain what that means, but it's because we're going to be working with count data. So this is the number of purchases a customer has made in a 2-week period and in the past period, okay? We're going to be also talking about a mixed effects model. This is a key term. I'll explain what that means, but we're going to be analyzing both as a global and also by customer. And then we're going to be using probabilistic modeling using Markov chain Monte Carlo. A lot of buzzwords there. That just means sampling, okay? A couple of key requirements before we get started. Make sure you have the BRMS library installed. This is for Bayesian models using Stan. Excuse me. And then also make sure this is a new package called Bayesian, and this is our Tidy Models adapter to BRMS. It is cutting edge, guys. This is brand new stuff here. All right, libraries we're going to load. We're going to first load the Tidyverse, Tidy Models, Bayesian, Poisson reg. So Poisson reg, so we're doing Poisson regression. We need this Poisson reg because it's going to allow us to do Poisson regression without the Bayesian. And then the cool thing is here, guys, this Poisson reg, anything you can do with a frequentist approach, you can actually do with a Bayesian approach, and you can get these awesome confidence intervals. All right. So Poisson reg, that's what that's for. Bayesian is for the Bayesian version of Poisson reg. Tidy Bayes, we're going to use that to analyze some Bayesian models, Skimmer and Plotly. Okay. So next thing we're going to do, we're going to pull in our data. So this is the data set customer offer experiment. It's in our data folder, Control Enter. And now we have our customer offer data. Now I need to explain something to you guys. We have 5 columns by 236 data points. So the order count is what we want to know because that's in our 12-week or basically a quarter period. We're going to be analyzing how many orders that customer actually makes based on which offer that they see. So this offer is either a 1 or a 0. Are they seeing the new offer or are they seeing the old offer? The age of the customer, the base, which is their previous order history, and we have a customer identifier. So 1, 2, 3, and we'll explain kind of what that is, but just think of it like an ID feature. Okay. So next thing I'm going to do, I'm going to make some adjustments to this. I'm going to make a couple of columns here, a factor. So now we have categorical data that we're dealing with. So we've got customer, which is a factor, and offer, which is now a factor. Remember, offer is 0 or 1, old offer versus new offer. Customer 1, 2, 3, 4, 5, all the way up to however many customers there are in the data set. All right. Next thing, we'll just quickly skim this to make sure there's no missing data and to kind of get another sense. You can see here, there's customer offer. There's either it's 100% completion rate for all of these, which is good. That's what we want. There's number of unique values too. There's 124 zeros, 112 ones. So again, 1 is that new offer that they're being exposed to. Okay. There's 59 different customers. Customer 1 is presented 4 times, customer 2, 4 times, 3, 4 times, and so on. More on that here in a second. And then we have the variables here. So order count is our target. We want to know how many orders will they buy within a 12-week period, the age of the person, and then their base, their previous order history. Okay. We can then arrange it by customer. And I just want to view this really quickly to show you a little bit more. So each customer in here is actually multiple times. So I have arranged it here by customer. And if you can see this here, it's 1, 1, 1, 1. So we have 4 samples that we produced, and we have their previous, their base, which is how many orders they've made in the past. And then at various 12-week increments, how many orders that they placed. Okay, so you see 5, 3, 3, 3. For this next one, 3, 5, 3, 3, and so on. Okay. All right, so that's what we're going to be modeling. Next thing, what we're going to do is I'm just going to quickly take a look at our target, and I want to group it by offer, and I just want to check out the density. So see if there's any key differences between offer 0 and offer 1. So this is 0 up here, offer 1 up here. It's kind of tough to tell. They look pretty similar, but excuse me. One thing that I can see here is that this one's a little bit lower, which means there's a little bit more under offer 1 that seems to be getting pushed up to higher order counts. But that could or could not be related to the offer. It might be related to something else in the data set. Like maybe we just had people who had higher orders previously, right? So we want to be able to analyze that. So we're going to be making actually a Bayesian model, a mixed effects model, and a linear regression. So the linear regression is our baseline. This is what we're going to compare our models to. And real quick here, so the way that this will be split up, we've got training and testing. We've got the standard Poisson regression, which is our linear regression, Bayesian Poisson regression, which is basically identical, but the Bayesian version, and then the Bayesian mixed effects. Now you will see I've got some long running scripts, so I don't want to spend a whole lot of time just like watching the model run. So I'm probably going to fly through those. Okay. So next thing, we're going to split up our train test set. So first I'm going to set the seed. What I'm going to do here, and this is a little unique, I'm going to take my customer offer, excuse me. I'm going to take my customer offer tibble and I'm going to take the distinct customers, because remember, there's multiple repeats of customers. So what I'm going to split out is some customers into a training set. So these are all the unique 59 customers. I'm going to take 80% of them, put them into a training data set, and the other 20% of them are going to put into a test data set. So when I run this, this will give me a training index, and I'm going to create a training tibble and a test tibble. Okay, so let's verify that the training tibble is 80% of my data. And I can see we've got now 188 columns here, or 188 rows by 5 columns. And in my test tibble here, I can see I've got, let's see here, test tibble, 48 columns or 48 rows. So that is about 20% of my data. Okay, so I'm splitting it up. Next, what I'm going to do is I'm going to do just a standard Poisson regression here. So Poisson is for counts. It's kind of like a linear regression, but it's special because we're dealing with count data, because we're not dealing with just like how much did that customer spend, but we're dealing with specifically how many times that customer spent money. Okay, so we're going to do this thing called Poisson reg. We're just going to set it to regression, and we're going to set our engine to GLM. Okay, so Control Enter. Next thing, I'm going to make a recipe. And the thing that I don't want to do is I don't want to include this customer factor in here. The reason that I don't want to do that is because these types of models can't deal with new customers. And we have in our test set completely different customers than what we have in our training set. So we want to be able to, we're going to remove this customer, and we're going to do what's called creating a global model. All right. So we're going to do that recipe spec here, order as a function of dot, and that gives us our recipe. We're then going to move on to our workflow, and a workflow takes two things, right, guys? It takes a model. So we've got a model specification, which is my Poisson regression model, and it takes a recipe, which is my linear recipe. So outcome, one outcome, 3 predictors, and we're dropping this customer column. Okay, so now we have a workflow linear. Looks something like this. It's not fit quite yet, so we now need to train that on some data. We're going to give it the training data, and we're going to call this thing workflow linear fit, and it's already done. So one of the key strengths with just the regular regression is that it's super fast. Okay, now you're going to find when we do Bayesian regression that it's a lot slower, and that's because it has to do this thing called Markov chain Monte Carlo, and that's a sampling approach. But the benefit is we're going to learn what not only the mean value is, or the average prediction, but we're going to learn what the distribution is. Okay, and it's really powerful. So strengths here, we're going to move on and do the same thing that we just did here, but we're actually going to do it with Bayesian. All right. So the strengths here, confidence interval is now determined based on MCMC, Markov chain Monte Carlo. Confidence becomes significantly more accurate. All right. So here's how you make a Bayesian model. First, you set your mode to regression. We're going to give it a family of Poisson, very similar to what we did with the Poisson regression up here. We selected this Poisson reg. Here, all we do is we give the family Poisson, and it's automatically a Poisson model. The engine we're going to set to BRMS. We're going to give it iteration of 2,000 times. So that's going to be 2,000 iterations for each chain. So a total of 4 times 2,000 is going to be 8,000 iterations. All right. So we're going to give it core 6, and that's going to speed up our modeling process. So this doesn't do any modeling. This just sets up the model spec. You can see I've got the model spec right here. Then what we're going to do is I'm going to set up the recipe Bayesian, and we're going to go from there. Next, what I'm going to do here, notice I don't have a formula. I've added a formula here, order count as a function of offer plus age plus base. Notice that I'm excluding the customer column, which is the same thing that we did previously. So that's a difference here between how we modeled this up here with the in the add model piece right here. We just added the model spec Bayesian, but we actually gave it a formula, and this is a Bayesian formula that we're gonna follow. Okay, but otherwise this is essentially identical. Now I haven't actually trained this yet, and the reason is because this is a very long running script. It'll take, normally without Zoom running, it takes like 30 seconds, but this is the line that you would run. Now, instead of running this, well, I'll run this. Actually, no, I'm not going to run it. I'm not going to make you guys sit here for 2 minutes while this thing runs. But what I'm going to do is I'm going to pull it in because I previously saved it over here. This model Bayesian, I'm going to pull this in. It's modeled on my training data set, right? So I'm going to pull that in, and we're going to take a quick look at it. So this is what this model looks like once it's finished. And you can see here, it's got some interesting things. It's got not only some estimates here of the intercept, the offer, the age, the base, but it also has lower 95 credible interval, upper 95 credible interval. And this is what's interesting. So offer 1, which is being shown here, has a 0.2 positive coefficient. And we can also see from the lower and higher end that depending, like a 95% probability is going to say that this is going to be positive. So that means that offer 1 is indeed having an effect on our model, a positive effect, which is good. That's what we wanted to see. So by sending out that special offer, we're indeed getting people to buy more, which is exactly what we want, right, guys? Okay, pretty cool. All right, next thing, we're going to keep moving along here. Now that we understand a little bit more about the Bayesian model, what I'm going to do is I'm going to do the same thing, but I'm going to create what's called a mixed effects model. And this is just an introduction. I want to give you guys a taste test about what you can do once you get deeper into the Bayesian world. So this is called a mixed effects model. There's also frequentist approaches, which comes from, I think, the Elmer 7 or Elmer 4, LMER4 library. And you can do this thing called mixed effects. But anything that you can do there, you can do in Bayesian, only better, right? Because you're getting probabilistic forecast or probabilistic modeling. So we're going to do this thing called the same type of model. So order count as a function of offer, age, and base. And then we're going to also say, okay, we want to do this within groups. And think about this, guys. This is mind blowing because we've got a training data set and we have a testing data set. That testing data set has totally different customers than what we're going to show here, but Bayesian can actually model these with a per customer grouping analysis. Okay, so I'll run this, and then you can see the key difference here is we've added this one given customer. So I'm not going to run this. This one actually takes quite a bit more time, so it takes probably like a minute to run, because we're doing a within group analysis now. Okay, so I'm not going to run this line of code. What I'm going to do is I'm going to pull it in over here. It's this model Bayesian mixed. We're going to pull that in right here. And now I have my mixed effects model. Pretty cool. So this is really amazing. So you can see up here that we now have this new formula. And it did 2,000 iterations, a warm-up of 1,000, four draws, 4 Monte Carlo chains, and so on. I'll explain what that means a little bit later. But this is cool because now we've analyzed it both without groups as a global and with groups as a local model. All right. So now that we have these models, what do we do with them? That's the next question, right? So let's inspect these models. So first, we already kind of alluded to this. It gives you some good information to start with. So this is just the regular Bayesian, not the mixed effects model. And it gives you some good information here. We saw that there's a positive 0.2 coefficient, but more importantly, we can see that the credible interval is between 0.09 and 0.31. So this being a positive coefficient, means that you're going to make more sales. Remember, positive means the model goes up. Negative means negative would have an inverse relationship. So this is giving us good information already. Next, what we can do is we can actually pull out what's called the BRMS model. So this was made using a package under the hood called BRMS, using the tidy models adapter. So if you know tidy models, you know how to use BRMS already. So I'm going to pull out that core BRMS model. Again, it doesn't look very different, kind of has the same printout that we saw. The only difference here is up here, you can see that this is actually part of a workflow, and then this is just the model now. Okay. All right. So once we have that, we can do this cool thing called plot. And this is amazing, guys. So you can actually see, once the plot gets pulled up here, I'll show it to you. It takes a second. There we'll go to the plots, and there it goes. All right. So just like a linear regression model, there's an intercept, and then there's coefficients for each of these key features, right? And the higher the coefficient, the more value it has to the model. So we've got B underscore offer, and you can see the distribution. So it did a bunch of sampling. That Markov chain Monte Carlo did 4 chains and 2,000 samples each chain. And it estimated what that B underscore offer won. So when it's 0, it's going to be less effective by 0.2. But when it's 1, it's going to give a 0.2 boost to your to your purchases. All right. So that's good news. That's good news. All right, cool. So now you understand a little bit more about what it's doing. It's calculating these coefficients using what? Markov chain Monte Carlo. All right. And it's giving us distributions. Okay. The next thing, we can also get our variables in our model. So this is using a tool called Tidy Bayes. Tidy Bayes is a fantastic package. And we can pull out the different variables in our model. The ones that we normally focus on are these here. And there can also be some other ones if we have a mixed effects model, which we do. And I will show you that here in a second. So we can spread what's called the draws. And you can actually dive into the results of your Markov chain Monte Carlo with the spread draws. You can pull out that B underscore offer and see all of the values of that B underscore offer one parameter, and that these are all of the calculated. You can see sometimes it's 0.18, sometimes it's 0.299, 0.251, and so on. Okay. All right. Next thing. Now that we can kind of see a little bit about how this model works, now what we want to do is move on to prediction, right? We built this model because we want to predict with it. So let's move on to Bayesian probabilistic prediction. So we're going to take our general Bayesian model, and here's what I'm going to do. We're going to give it some probabilities here. So I'm going to be using this thing called type raw, and we're also going to use allow new levels. While that's not super important for the global model, because we have new customers in our data, for the local model, this is going to, or the mixed effects model, it's going to become important. So what I'm going to do is I'm just going to run down through, I'll run line by line through this code because it gets a little crazy. So what I'm doing is taking my model, making some predictions. It comes out as a matrix, and I'm going to convert that to a tibble. And then what I'm going to do is I'm just going to clean up the column names here a little bit. And we now have our probability estimates. So keep in mind 0.17 and 0.83 is like a 66% range. So 2/3 of our data should fall within that. And then 0.2025 to 0.975, that's our 95% credible interval. Okay. All right. And then we just clean up those names and we'll save it as prediction Bayes. I'll show you what this looks like. It's just basically formatting. Okay. Let's see. Okay. So we got prediction Bayes built. This is what it looks like now. All right. And again, this was on my test data set. So the holdout set. And what we want to do is we want to see basically how our predictions stack up and also our probability estimates stack up. So what I'm going to do here is I'm actually going to integrate the Bayes predictions with the LM predictions because we want to compare these. So I'm going to take my predictions. I'm going to just select the .pred column. I'm going to rename it .pred underscore Bayes. And then what I'm going to do is I'm going to add in a column called .pred LM. and that's going to be from my linear fit. That's my Poisson regression model. Okay. And then we're also going to add in the actual data. So when I run this, here's what it looks like. Control Enter. And it's should just be 3 columns. Control Enter. See, prediction, LM, and Bayes. So we've got prediction Bayes, prediction LM, which is the Poisson regression, and then our actual data. So what we want to do is we want to compare these two. Okay. So I just want to see here real quickly how prediction LM works. We got an estimate of 21 for RMSE. We got an estimate of 8.85 for the Bayesian version. So it's Bayesian looks like it's doing quite a bit better. But here's the beauty here. Okay. With Bayesian models, we don't just get the prediction, right? No, we actually get distributions. So I'm actually going to switch over here and I'm going to take a look at the mixed effects model, because this is the one where we look at the individual groups. And I want to show you how crazy valuable this is. All right. So not only did it make a good prediction, but we can actually do even better. We can get the distributions. So this is what the mixed effects model, remember, that's what where we did it as a function of the customer. Okay. So each customer is going to be locally analyzed. All right. We're going to do that same predict. Now, this is where I have to have allow new levels true, because we have new customers coming into the test data set. So when we do that, we're going to do the training data set first. We'll do the test data set second. So allow new levels doesn't really matter for this first one. We're going to do the same process with the probabilities. And then what I'm going to do is I'm going to do some column binding. So I'm going to take my training tibble, and this is in sample right now. We're just analyzing in sample. We'll do out of sample next. So I've got my training, and then I've got my predictions and the confidence intervals. Okay. And what this is going to do here, let me just show you all this code. I'm not going to spend a whole lot of time going through all of this code, just because it's basic visualization stuff you guys probably already know, right? So I'm going to run through this. And what this is going to do is it's going to produce a visualization. Okay. So I'm going to, we stored it as G. And this is what the visualization looks like. Let me open it up a little bit. All right, it's taking a second. Probably a lot of data points. And plus I have Zoom running, which always takes a little bit longer, right? So just give it a second here, guys. And let's see. All right, there we go. So this is the cool thing. Now, this is a static plot. So we have all of these different customers in here. And what we can see here is that these distributions here are they're shrinking and getting larger depending on what the variance is in the model. Okay. So when it's very low, that distribution gets really small. But when it's high, meaning that customers making lots of orders, and these black dots are our predictions, you can see that the variance actually spreads. And that's what you cannot do with normal linear regression or normal Poisson regression, right, guys? So this is the value of the Bayesian approaches. It's amazing. You're getting a probabilistic prediction that's capturing 95% of the data, okay? And we can make it interactive here. I'll just run this one real quick. Hopefully it turns up. Yeah, that one ran a little bit faster, and we can zoom in and actually see how large this variance got. Yet when I scroll down here to some of these lower predictions where the model knows that variance is smaller, it's being shown to be squeezed. Okay. All right, cool. So next thing that we can do, what this does is we're doing the same approach here, but all I did was I swapped it out with the test tibble because I want to see how it also predicts on data that this model has never, ever seen before. So we're just going to run this same approach again here. We're going to create the prediction Bayes on the test data set. So this is now, let's see here. It should be 48. Yeah, 48 total rows. I can see it's 38 rows down here, 48 by 5. Okay. All right. So we've made now our predictions with our confidence estimates. All right. And now we're going to predict on new data, and we're going to take a look and see what happens. So I'm just going to do the Plotly version for this one. Okay. All right. So let's check this puppy out. We have literally just predicted on data this model has never seen before. And look at this, guys. For the most part, it's doing pretty good. Now it did miss on this one. You know, this customer ordered 18 and it's predicting 72. But for the most part, you can see that the new predictions 14, and you can see that the customer actually purchased 22, but 6, but 12. So it's like kind of dead in the middle, but the variance, the distribution of that forecast is capturing the risk in our model because it knows now which customers have higher risk of the model being incorrect. So think about that, guys. What do you think the conclusions are that we now know which ones have higher risk of that model being wrong? What can we do with that information? So I've got some conclusions for you guys. That wraps it up. That wraps up the 300 lines of code. Now I want to talk about some conclusions. All right. So what did we learn here today? We learned here that the organization is able to understand their confidence in the model, which helps us know which offers to send specific people. We saw that offer one, that in that model, it actually moved, right? So it was a 0.20, which is a positive number, which means that the order count would increase if that number of 0 or 1 gets converted to a 1, okay? That means that the offer has a direct impact. And that 95% credible interval showed us that it was that full distribution was positive. So there is virtually 95% probability that offer one will give you more sales. Okay. This is what we did, right? Does everyone agree? Let me ask you a question. Do you guys agree that that's what we just did right now, right? All right. I'm seeing some yeses. I saw Steven said no. All right. All right. All right. So what do we really do? Well, let's think about this differently. Here's what we really did. We just single-handedly discovered a framework of Bayesian analysis, which allows us to understand the downside risk in our model, meaning how much risk or how much variance. So if we just calculate that risk about how much we're at risk of being off. And this is the thing back when I was working at Bonnie Ford's that I could never do. That's what we did here. So think about that, guys. You can now make better investment decisions for, say, like capital projects, like for me, the fast track program, or even your own financial investments, stock analysis. You know the risk now with being wrong. So you're not just predicting the stock to go up, but what's the probability of it going down? Think about that. This is how you can save organizations $1 million or more by reducing the risk of being wrong through probability. And that probability changes depending on what you're analyzing. That's something you cannot do with linear regression right now. So one question for you guys. Do you know how this will help you get a data science job? Answer for me in the chat. All right, I'm going to answer for you guys. Probably not. Probably not. See, I gave you a lot of information, but here's why. There isn't an A to Z path for you to go from here as soon as you leave this training to becoming a data scientist. So I made one for you. I'm going to help you guys out. Here's what it does. This is David Espinola. David is a student in my courses, and he just got a job as a machine learning support engineer just a few weeks ago at Microsoft, one of the biggest companies in the world. He's doing machine learning. He says here that your courses gave me the confidence to get through the interview process. You see, that's a key thing you're going to need to be able to do, is to be able to show in the interview that you can provide value. Here's another example. How long is it going to take you? Well, here's Justin. He's now the lead data scientist at Northwestern Mutual, and he's a friend of mine, and he's a student. And he told me exactly how my program helped him. He says, in less than 6 months, I had fully transitioned into a lead data scientist. And that was after starting his first business science university course. So remember, guys, the trainings that I did with the elite companies, I've actually packaged them into a system. And now he's the lead data scientist at Northwestern Mutual, one of the biggest insurance companies in the US. But it doesn't just stop there. Ben Wynn Morris. This particular testimonial drives a point home with me because it actually took me 5 years to even become confident in data science. So what you saw today, it was just a demo. And I know something because I was able to teach you guys Bayesian in about 45 minutes to an hour. But the truth is, it took me 5 years. So it took Ben as well. He says, amazing. After 5 years of struggling to find the right opportunity, I now have 2 job offers, not 1, but 2. So he is in the situation that every data scientist needs to be in when they're getting a job. They need to have multiple offers so you can pit these companies against each other. And that helps you to be able to negotiate. So he was able to get his dream job. He's now a data scientist of AI and ML quant at Argus Media. Fantastic. And Jennifer, she is now the VP of Strategic Analytics at JP Morgan Chase. And she says here, thanks to Matt and what I've learned so far, I was able to do an in-depth analysis of Consumer Financial Protection Bureau data during her interview. She did this by following my business science problem framework and completing a project using our Markdown. This polished, finished product impressed the hiring manager so much, he was willing to fast track an offer. And she got her dream job as VP of Strategic Analytics. So this is what I want to be able to do for you guys, everyone that's on this call with me today. But you got to think about it. You've got many options. I know you have options. In fact, I've analyzed them. Here are your options. You got option A. You can go back to school. It's going to be a lot of money, and it's going to take you about 4 years. And by the time you get out, the tools will all have changed. And the big problem is companies actually need to fill positions right now. In fact, data scientists are in super high demand. I know this because their salaries are skyrocketing right now. Option B, you can do what I did. Learn it yourself. It took me 5 years of trial and error, just like it did Ben, and it cost me a lot of time. Plus, remember, guys, companies need to fill positions right now. So you can't afford to take 5 years. It's going to be an $8 million mistake when you factor in how much money you could have made over that 5 years and all the promotions you could have gotten. So there is a third option. This is option C. You and I work together. I can teach you, but you must be motivated, able to dedicate 10 hours per week, willing to follow my system exactly, and you need to communicate with me as soon as you get stuck. Does that sound fair to you guys? Does that sound fair? Let me know in the chat. Okay. All right, I'm seeing some yeses. Who wants to see my A to Z path? You guys want to see it? See what it looks like? Just a sneak peek. All right, I'm going to show you guys. I'm going to frame it in the skills as skills that you need in order to be able to get a job. As soon as you leave here, these are the exact skills that you need. You need foundational skills, okay? You need business problem solving skills. And that means you not only need to learn how to do analytics, but you need to be able to apply it to business problems that you're going to see in the real world, okay? You need to also understand time series forecasting. You have to be able to build tools for yourself, and you have to also be able to build tools for your company. If you can't do any of these, then you are severely limiting yourself in being able to get a job. And then once you get on the job, be able to get results. You see what I'm saying? Does it make sense? Okay. So let me frame this in another way. These skills all can get you different positions, and it depends on what your goals are, right? So if your goal is to become a data analyst, then you probably just need to get some foundational skills, and you can do some reports and make some graphs and impress some people. Okay. But if you want to become a data scientist, you need more important skills like actually applying machine learning to business problems and doing time series forecasting at scale. And you have to also be able to build tools so you can actually show and automate these processes. Okay. Now, if you want to become a senior data scientist, and here is the secret, you then not only need to be able to do all of these things, but you have to be able to build tools for your company that your company will actually be able to use. We call this production. All right. So there's a second problem. Big problem number 2. No one teaches you that A to Z fashion. Until now, guys. Until now. All right. So let's see what this looks like. There's a system that I put together, and it starts with a first course called Data Science for Business Part 1. All right. Here's what Data Science for Business Part 1 does. First, it gives you the foundations of data science so you can perform basic machine learning. It allows you to produce high quality reports that businesses can use to generate insights. It helps you to clean and work with data, visualize data, which produce those insights, and you learn machine learning algorithm foundations, very important as you progress in your journey. These are all the general foundational steps for all data scientists. Okay, so that's what this first course does for you. Now, here's what you're going to get. So the first part is Data Science for Business Part 1, and that has a $599 value. Okay, but wait, there's more. We now need to cover business problem solving skills. So here's what's going to help you do that. So for business problem solving, I'm also going to give you Data Science for Business Part 2. And what Part 2 does is it helps you by solving a $5 million per year business problem using a repeatable framework that can be applied to almost any business problem. And yes, this is the same framework that allowed Jennifer to get her job at JP Morgan. All right. You learn by solving the entire business problem step by step as I walk you through it. You use advanced tools, including automated machine learning and explainable AI. And we don't just stop there by developing models, but you actually develop a financial decision-making solution using return on investment to show organizations exactly what they want, which is savings. Okay. So by the midpoint of this course, just 50% through of it, you are using state-of-the-art H2O automated machine learning to produce hundreds of predictive models. Pretty fascinating, right? Well, it's not only cool, it's actually pretty powerful. So this is a testimonial from Augie, and I just want to show you the power in just this second course alone. So what he learned in this course helped his company save $5 million per year. Imagine how valuable you would be if you saved your company $5 million per year, right? Well, if you read this testimonial, he says down here, the skills displayed during the project were a major consideration factor in my promotion to analytics manager a few months later. And it was all thanks to the skills I picked up in your course. And we're just talking about this Data Science for Business Part 2. So imagine what the other parts of the program can do it for you. All right. So here's what you're going to get. You're going to get Data Science for Business Part 1, and you're going to get Data Science for Business Part 2, a combined value of $1,600. All right. Next, we need to talk about time series forecasting. Okay. So for that, I'm going to give you my high performance time series course. And what you're going to learn in there and what you're going to do is you're going to solve a special type of problem that costs organizations millions of dollars per year. And how are you going to do this? You're going to learn strategies from 4 competitions that I spent months analyzing. And you're going to use custom software that I wrote to make forecasts at scale. So this is actually software, and you can see the logos right here that I personally built myself. And we're talking using these on thousands to make thousands of forecasts. Companies like Walmart are drooling over people with these skills right now. All right. You're going to use advanced techniques like machine learning, deep learning, and feature engineering. And in just the first 30% of this course, you're building powerful forecasts like the ones that are shown here. Look how good this is, guys. It's getting all the spikes and everything. And it's got the confidence interval around it. So let me talk about the power, though, because that's what it really means. It's the results. What can you get from getting this course? So this is Amit. Amit is now the machine learning senior associate at PwC. And let me read you his testimonial. So he says here, I want to say I am extremely grateful that I found you and your courses last year. I used to feel imposter syndrome. He says here, I would not have my new job if it wasn't for you. Man, that's powerful. So let's talk about how he got that job. This is about the interview. He says, this helped me move to when he's talking about the course, the time series course, just the time series course, guys, helped me move to the final rounds. I was able to do everything within 2 days. And if it wasn't for your courses, it would have definitely taken me longer. And I don't think my results would even have been half as good to move to the final rounds. And he even gave me his report. And trust me, guys, this report was amazing. So it helped him get his dream job. So guys, you're getting Data Science for Business Part 1, Data Science for Business Part 2, and my high performance time series course, a total value of $2,400. But we need to talk about what are you going to do for your company once you get all these skills? And that's where Shiny comes in this next course. So we're going to talk about my Shiny Web Applications Part 1 course. So guys, this is amazing. You are going to learn the foundations of production for data science. You're going to learn how to build web applications. You're going to learn how to automate key business analyses and processes, and basically empower your company to make data-driven decisions for years to come, so they don't have to come to you each time asking for answers. They can just use a Shiny web app. So what is a Shiny web app? Well, here's an example. In just the first 25% of this course, guys, this is amazing. You are building Shiny apps that use geographic maps that look like this and date range inputs that look like this right here, as shown in this. And look, guys, we're only like, if you see this bar here, this is the top, this is 25% through. You're already building this. Like, the power of this course is ridiculous. All right. So you're going to get Data Science for Business Part 1, Data Science for Business Part 2, my high performance time series course, my Shiny Web Applications Part 1 course, guys. Total value, $3,196. But wait, there's one more. We got to get you to senior data scientist, right? So we got to teach you how to build tools for your company. Remember, guys, senior data scientist, that's like $150,000 career, right? That's my goal with this training. It's not just to get you a data science job, it's to keep getting you promoted. So we're going to give you the Shiny Web Applications Part 2 course. And what do you learn in there? You are going to learn cloud technologies using AWS and Docker. You're going to learn how to scale and deploy data science. You're going to add security authentication, which is a requirement for enterprise solutions. You're going to learn how to connect backend databases, customize user interfaces, integrate an API, everything that you need to know to deploy applications in the enterprise, guys. This is insane. So let's check it out, guys. The amazing thing here is that you don't just build what you're seeing here. So this is the stock analyzer. You don't just build this app, but you actually deploy it using AWS cloud technology, Git and GitHub for production code, and you learn Docker and Docker Hub for the production environment. These are, guys, these are the exact skills that companies are paying senior data scientists $150,000 per year or more. All right. So I need to let you guys in on a little secret. Here's another secret for today. This is one of my students, Mohana. He took this course last, and this is what got him all of these raises. So he says, after your entry into my life, he was getting 3.5% raises. So just in another 6 months, I got a 3.5% hike, just normal hikes. But then after that, I got a 10% hike. And then after another 6 months, a 26% hike. And then after that, another 2 months, a 40% hike. He says, I could be able to grab a job wherever I want. And I told him, I'm so happy for you. This is what happens when you invest in yourself. So I don't know if you guys know this, but that's a total of 94% raise in 8 months. So think about it. If he started at 75K, like a business analyst might start at, he was making $150,000 by the end of it. And that's the secret, guys, to being able to deploy web applications. See, Mohana, he began outproducing his coworkers threefold by using the processes and the techniques that I teach. All right. So let's recap. Here's what you guys are going to get today. Data Science for Business Part 1, Data Science for Business Part 2, my high performance time series course, my Shiny Web Applications Part 1 course, my Shiny Web Applications Part 2 course. Total value, $3,995, but that is not what you guys are going to pay today. So you guys have spent over an hour with me on this call. So I'm not going to disrespect you with that. Now, normally you would pay $2,497 for this. However, you guys have made a significant investment today with me. So I owe it to you guys, and I want to get you guys kickstarted today. So we're not going to make you pay $24.97. We're going to have the final offer at $19.99, guys. This is a 50% off value until Friday at midnight. Now, I do have a special link that I'm going to put in here. So I'm going to copy this link address. I'm going to put it in the chat right now. And what we're going to do is talk quickly about how you guys can get started with this offer today. So as you can see here, guys, this is what the offer looks like. So I just put the link into the chat. If you guys want to check it out now, you guys can follow through with me. So it's the 5-course R-Track system. You're getting 50% off, and this is available for the next 2 days and 22 hours. Okay, so about 3 days. It's a total value of, like I said, $3,995. You're getting it for approximately half off. And if you go through this process, we've made it super simple for you guys to get started. So here's all you have to do. It's very simple. We just put our name in here, Matt Dancho. You put your email address in here, and dancho@business-science.io. The item is already pre-selected for you. I'm not going to enter my credit card information, but once you start entering that in, and let's then enter your normal information, and then you click the complete order button. Okay, it's that simple. What will happen next is you will get an email from me saying that you have been enrolled in the course, and you can get started today, guys. And you're going to get all 5 of my courses. The recommended order, because I always get this question, is Data Science for Business Part 1, Data Science for Business Part 2, High Performance Time Series, Shiny Web Applications Part 1, Shiny Web Applications Part 2, and that's the order that I recommend that you guys take them in. Now, I will say this, I do get questions about if there's a payment plan. Unfortunately for this offer, because it's such a significant discount, we do not have payment plans available at this time. You can, however, go onto my website and you can check out the normal, if you go to business-science.io, and I'll show you how to get to it. If you go to the courses, and you can go to the 5-course R-Track system here, and then you would just scroll down to the bottom. So you go to enroll in course, you'll see all the testimonials, and then you can see that you could buy it right here for $250 per month. Okay. Unfortunately, the discount does not apply to that. You can see here that this web page has $19.99. Oh, We got some information in there I don't want you guys to see. Sorry. You can see here, 1999. There we go. All right. Next. I'm here to answer any questions at this point in time before we move on. So I want to go through the Q&A, and I know you guys have been super patient with me. All right. So I have a bunch of questions in here. Let's check them out. All right. So the first question, will this be posted on YouTube? And this is from an anonymous attendee or somewhere. It's 2 a.m. where I am, and I have work tomorrow. Unfortunately, I am not posting this on YouTube. So this will be immediately after this is done. I'm going to be adding it to my Learning Labs Pro program. And if you enroll in the 5-course program, you will get a special offer on Learning Labs Pro as well. That'll be the next page that you see. If you want to get the recording of anything in the code and the slides that you saw today, those will be added into my Learning Labs Pro program. There's like 70 labs in there, but I highly recommend that you get started with the R track. The R track is what will get you all of the results that we've seen here, from getting data science jobs to getting raises, to getting promotions, to working at Microsoft, JP Morgan Chase, Northwestern Mutual, and so on. That is what I highly recommend. That is the most important program that you need to be focused on right now if you're beginning your data science journey, okay? Or you need a job in data science. All right, second, let's see. Ashray asks, is this going to be available later as well? And the link to the code and the analysis. So Ashray, I just explained that it's going to be in my Learning Labs Pro program. So if you enroll in the R track, there will also be a special upgrade offer if you want to join Learning Labs Pro as well. Okay. Murray asks, my biggest challenge with Bayesian analysis is that leaders have little to no understanding of statistics. They immediately shut down when they see a probability distribution. Any suggestions for overcoming this? So Murray, this is a great question. In fact, I heard it from Kristen Kerher earlier this week. She had the same issues with Bayesian and trying to roll that out in her work. The best thing that you can do is say, okay, let's set probability distributions aside. And let's just kind of set that aside for a second. Let's say we just made a correlation, right? Something simple, like we correlate the results that we got from our Bayesian, and we saw that offer one has a positive correlation, which we know it does, with increasing the revenue for these customers. We saw that. We know it does. If you run a correlation right now, it will. Guess what? Most business leaders actually do understand the idea of correlation. So you can frame it, if you can just tweak how you frame the answer, and you say, all right, hey, this is what information we saw. And then the Bayesian model, so Bayesian, is going to help you then characterize the probability. And that's all it's doing differently. So instead of doing a prediction now, so we take a correlation, like in a linear regression, that's what we would kind of do. We would do a regression. Think of like linear regression as like kind of correlation on steroids. Well, the next best thing to Bayesian is like a step up, where we do the same thing as linear regression, but this time what we do is not only characterize how the linear regression predicts, but how the probability distributes based on the spread of the data. Okay, so that's how I would explain it. I wouldn't get too much, again, focus on what they understand. Correlation, start there. If they also understand linear regression, move to that next. And then if they can understand linear regression, then suggest that all Bayesian is just a probability on top of that. You know, no big deal. Okay, that's how I would explain it. All right, Ralitsa asks, are we going to get the R code after the lesson? So the answer is, if you enroll in the R track and you take the offer for the Learning Labs Pro, then you will get the R code. However, again, the most important thing right now is, if you want to be able to do the things that you saw in this lab, either one, hopefully you took good notes, but number two, what I would recommend is check out the R track. It's going to help you. Trust me, guys. This is the system that will get you from where you are now to where you want to be. If it's getting a job, if it's learning data science, if it's breaking through all the things that's holding you back, this will get you the results. So don't be overly short-sighted in just getting the code for what you saw today, but instead look at the big picture, which is doing what you need to do in order to advance yourself in your job. And that's what this system will help you do. Does that make sense to everybody? All right. Nisarj asks, where can I get the data in the model? Nisarj, so we can get you into, Nisarj is one of my students. We can get you into Learning Labs Pro. I'll talk with you separately about how to get into Learning Labs Pro. All right. Anonymous asks, you chose Poisson because the distribution of 2-week order counts is Poisson, in which case you need to figure out the distribution first. Well, we also know that it's counts. So we can kind of simplify it. A lot of times count data tends to be like very heavily distributed, one order or 2 orders here and there. But then you have some, more rare occasions where like it might be like a super customer, right? And they order like 50 things from your company or 100 things from your company. Well, that is a Poisson distribution. So that's why we chose Poisson. I know I didn't really explain that. That wasn't really the focus of the lesson, but that is why we chose Poisson as opposed to just a normal regression. Hopefully, does that make sense to everybody? Does that make sense to you guys? All right. Okay. All right. Jean asks, I have another meeting and cannot stay until the end. I enjoyed what I saw. Is there any way to still take a look at our cheat sheet for those who had to leave early? Unfortunately, if you had to leave early, I'm not going to give you guys a cheat sheet. I'm going to give you guys all access to that here in a minute as soon as I get through everybody's questions. But everybody has been waiting super patiently with me. And I want to make sure I do it justice and give people the information that they need. Jamie asks, is the credible interval different than a confidence interval? Yes, it is different. They're the same concepts because what you're trying to do is basically put a probability around what the chances are of a data point falling within a certain range, right? But there's major issues with the confidence interval. And I've known this because I've seen it done in the past, especially when you're using in-sample data, which is what most algorithms do. They create a confidence interval that's based on in-sample data. How dumb is that? That is so stupid because in-sample data, your model has seen that data. You need to create an out-of-sample confidence interval. So that's the problem with what most people do and the mistake that everyone makes. Now, what Bayesian does with the credible interval is they do Markov chain Monte Carlo sampling, MCMC. And what that does is just a fancy name for sampling thousands and thousands of times. And what they're doing is they're characterizing the true distribution. And that's why when we saw that when we did the out of sample data set, those distributions looked almost perfect based on the predictions, what the predictions were. So that's a major benefit for Bayesian. And that's why we want to use Bayesian if we truly need not just the prediction, but we need to know how confident we are in that prediction. And that's why Bayesian can help you. All right. Hopefully, does that make sense? Jamie, does that make sense if you're still on the call? Okay. I know that was kind of a long explanation, but I want to make sure it sank in. All right. Wycliffe asks, how do we include priors in Bayesian models? Okay, so I didn't talk about priors, and I did that on purpose, guys. I want to save that to the next Bayesian talk because we're going to do another series of webinars. We're going to talk about GAMs. We're going to talk about some more advanced modeling techniques, and we're also going to talk about some more fundamentals and foundations that I didn't cover yet today that are really important if you really want to do Bayesian the right way. So we can add priors. That's the good news. The bad news is you got to wait a couple of weeks until I do the next talk on priors. But I'm going to be covering a lot of cool stuff like GAMs, like multi-level models, hierarchical models, really crazy stuff that you can do with this Bayesian package and the BRMS models that I showed today. All right. William asked, and William's a student. He asked, can you discuss important assumptions that must be made or must be met for Bayesian inference? William, I didn't put the assumptions together for today, but the good news is that what I can do is I can take your question and I can copy that down and then add that for the next talk that we do on Bayesian. Does that sound fair? Hopefully that's good, because I wasn't prepared for this one. All right, cool. Amian asks, hi, awesome tutorial. Are we going to get the code? Thanks. The news is, if you didn't hear the first couple of times that I said it, we have a 50% off offer for the R track. The R track is what you really need to be concerned on if you want to level up and get your data science job and honestly start your career in data science. Next, if you need Learning Labs Pro, which has the code that you just saw today, plus the code for 73 other labs. So this is Learning Lab 74, 73 other labs. Think of these like projects. You're going to be good for you, if for special topics. And we're going to give all of those to you. But like, what are you going to use it for? You're going to use it to solve problems at your work, maybe that are pretty closely related, or you're going to use it for your project portfolio at work, like to get your job. So what I would do is if I were learning, I would just take a strong look at the 5-course R track, and I'll put this into the chat here. So let's put this in the chat here one more time. You guys can check out that link. That's going to help you get your data science skills leveled up. All right. That's going to get you not just leveled up, that's going to get you your dream job. And that's going to get you also promotions to senior data scientist. But if you want the code that you saw today, there's an extra offer. So you're going to get a significant discount on Learning Labs Pro if you opt in. That'll be the second page that comes up in that offer. It's the next step. If you want it, you can take it. If not, no big deal. You just finish checking out, and you're going to be all set. Everything you need to succeed. All right. Zach asks, does the Bayesian package also work for nonlinear mixed effects models? Yes, it does. We're going to go over that in 2 weeks. I can't wait. I'm super pumped for this, because Bayesian actually does way more cool stuff like mixed effects, nonlinear mixed effects models, GAMs. We can do the same thing that we do for GAMs, but get the distributions. So we can do nonlinear GAMs like for time series. So there's so many things that Bayesian can help us with. And we're going to see examples of this in the upcoming lessons that I have planned in this series of learning labs. Pretty amazing, right? Okay. Anonymous asked, maybe I missed this, but what did you use as the prior? So I just went with the default priors. I did not change anything. And in the next sequence of labs, we are going to be talking about how to actually change some of those priors and do some more advanced modeling. Okay. Rajiv asks, hi, Matt, Rajiv here. Does Bayesian models give you significance for each parameter? Does it matter or a coefficient is enough? So this is the beautiful thing, Rajiv. If you remember, so in those plots, if you remember, those kind of like not the densities, probability densities for the individual parameters. So it not only gives you the actual measurement, like the average or the median, but what it does is it gives you the entire distribution. You can actually extract that from the model, from the BRMS model. They're called spreads or draws, and you can see how that parameter was determined and actually recreate the histogram. You can also get a summary of that histogram too. It's really, really cool and really powerful. All right. Let's see here. That was Rajiv Nasarj asks, can you explain the prediction plot again, real quick? So the prediction plot, yeah, let me pull it up. So this is what the prediction plot looked like. This is for the out of sample data set. So we have different customers. So what I did was I have like all of these different customers and how many orders they made over a 12-week period. And then I have this black, which is our model's prediction. But you can see there's a dark gray and a light gray. That dark gray is our 66% credible interview. And see, it's not, you can see here that the spread actually increases based on the variance, based on how much spread is expected for that particular customer's purchasing behavior. Okay. And that is the power of what these Bayesian models can do for you. They can actually give you that spread, and you know your risk, because if the spread is real large or if it's real small, you know that there's a percentage chance that your model is not going to be correct. So like when I planned on getting, $2 million from the US market, and my model's variance would have been like, super high because it was a brand new product versus a more established market. I should have known, hey, don't predict 2 million. But I went with what the model said. That was my first mistake without thinking. This was back in 2016 timeframe. So it was a different map. Please forgive me, guys. Please forgive me. All right. Anonymous asks. So interesting. Wish you had kept mixed effects out of this presentation. I am confused. I apologize about that. There is the basic model, and then there's the mixed effects model. I will explain more about mixed effects in upcoming lessons because it is more of an advanced technique. But for every one beginner, I usually have, one or two experts also on the call. And those people would probably be saying the opposite right now. So they would be saying, Matt, why didn't you do mixed effects modeling? Don't you know that that's the true power of Bayesian models? Well, I had to balance it. So I apologize if I confused you. But again, I'm trying to appeal to my audience, which, some are experts, some are beginners. Milan asks, do you have courses adjusted for Python? I do have one Python course, but it takes me like 6 months per course. So the progress has been a little bit slow on that one for my second machine learning course, but I will eventually get there. The good news is if you want to learn now, we have the R-Track system, which is available right now, which will get you a 6-figure data science job. And all you have to do is commit. And if you commit to me, I'm going to help you get through there. Remember, 10 hours a day or 10 hours a day, 10 hours a week. You need to reach out to me if you have any problems, and I will get you guys there. You just have to commit. And when you do that, you will learn data science for business, and I will stop at nothing to make sure that that happens. All right. So again, you guys have that for 2 days and 22 hours, 50% off. Make sure you guys get it before it jumps back up, $3,995. All right. Let's see here. Keep going. We've got some more questions. How do the part 1, part 2, et cetera, map to the prior 5-course series? So the part 1, part 2. So there's data science for business part 1, data science for business part 2. I think I kind of explained that. I can go through that again though. So if you guys check out let me see the system. I want to show you guys kind of how it maps out. All right, here, this is what I want to show you. So if you guys think about it, think about career: data analyst, data scientist, senior data scientist. So that's what you want to do with your career. If you want to become a data scientist or senior data scientist, this is the program for you. If you want to just be a data analyst all your life, then just maybe take a look at the part 1. Okay. But how this maps is you get your foundations first, and this is the prerequisite for everything else. Then you learn business problem solving skills. Remember, like the $5 million problem is what I'm going to teach you how to do step by step. Then I'm going to teach you another $5 million problem, which is time series forecasting and how to forecast more accurately than anybody else on the planet. And you're going to become the time series expert for your organization. Companies like Walmart, they will be drooling all over you because they need your skills right now. Then you get the building tools for yourself, which is how do you deploy, how do you take the knowledge that you learned in these first 3 courses, and how do you productionalize it? Give it to somebody else who's non-technical. They're a business person or an executive, and they need to be able to have an app that they can run and do point and click interface, and that'll run R behind the scenes so you can automate all of your processes. So the first one teaches you how to do that for yourself. The next one teaches you how to do that for your company at an enterprise level. And that, my friends, is what senior data scientists get paid the big bucks for. Cloud deployment, more technical data science. That's going to help you get that $150,000 job. So you can see the full path, the full journey that you need to do. And you can see that the R track is the key. Each one of the courses solves a different problem, and it gets you to the end progressively. So while it takes forever, if you try to start here by like learning web apps, it teaches you the foundations first, which is what you need for these 4 courses. Then you learn the analytics, which is what you need to be able to then productionalize, because you have to take your analysis, package it into an app, and then you learn these, time series forecasting, special types of apps that can really save your company a lot of money. And I'm telling you guys, Shiny is the most underrated software in data science, because it is so powerful for organizations. You have no idea. I actually just this past week got offered a gig for $50,000 for creating one Shiny app. It's using the techniques that I teach in this course. $50,000 for one application, guys. I'm not going to tell you who sent it. I'm not going to tell you any more information about it, but that's the power of these courses. All right. So hopefully that makes sense. All right. So again, 5-course art track. It'll really help you guys out. Next here, let's see, where am I at the QA? Let's see here. How long does the program take to complete? So this is largely up to you. I recommend 10 hours per week. If you do less than that, it's going to take you a lot longer. If you do 10 hours per week, if you don't take any breaks, you'll get it completed in 6 months, and you'll be in a great position to get a data science job. But if you do only 5 hours per week, it's probably going to take you a lot longer, probably 12 months or even longer, because if you're only doing 5 hours per week, you're going to forget a lot more. So you need to balance. If you've got, I understand it is designed for people who have jobs. So when I was taking my MBA, I was spending 20 hours per week on my coursework. Now I had to do that for 2 years straight in order to be able to get my degree. And I didn't learn a fraction of what I teach you guys in this course or in this program. So I'm telling you guys, if you can buckle down for 6 months, set up a schedule, stay motivated for 6 months, 10 hours a week, ask me questions when you run into errors, problems through our Slack channel, for our private exclusive Slack channel, just for our members, for our course students. You're going to get your data science job. It's that simple, guys. It really is that simple. All right. Next question. Hey, Matt, I'm already subscribed to the high performance time series. Do I get a concession? So Swapna, I'm going to put my email in the chat. And what I want you to do is just email me, and we can set you up with a custom offer to help get you in the door. All right. So just send me an email. And for everyone else, I'll also put the link in the chat to the 5-course art track special. All right. Anonymous asks, I think the biggest problem is a company's IT team. They can never deploy complex models, always asking for simplicity. I didn't see with the Bayesian models how IT can put them into production, into simulators, websites, etc. And here's the beauty of the program. So Anonymous, I'm glad you brought up what we call the IT bottleneck. See, information and technology, the IT department in every company is backlogged. And we're talking, they have years of work. And if your executive team doesn't prioritize you above everyone else, your app is never going to be completed. It's the biggest joke I've ever seen, because IT departments, I used to see this time and time again in organizations, because these data scientists were sitting there like, oh, I did a machine learning model. When is my IT group going to put it into production? They're not, guys. It's got to be on you. And this is why I teach the last 2 courses, guys. I'm telling you, Shiny Web Apps Part 1, you're going to learn how to build web apps. Shiny Web Apps Part 2, you're going to learn how to deploy those web apps. So while your data science counterparts are sitting there twiddling their thumbs, waiting for IT to help them out, which is never going to happen, by the way, you're going to be deploying apps. This is why Mohana got 94% pay raise over an 8-month period, because he was outperforming his data science counterparts. Think about it. He got a raise after 10% after the first first 2 months. Then in another 6 months, a 24% raise. And then in another 2 months, a 40% raise. because he was churning out app after app after app. And those shiny apps, guess what? The executives see those, they like them, they love them, they are like super excited about them, and they want to know who built them. When they start asking that question, they see that you've built 3 shiny apps while your whole data science department hasn't productionized 3 models yet, they are going to be like, woo, promote this guy. So you see why this makes you super valuable? It's because you impact your company way more than anybody else. And I'm telling you guys, I just got a $50,000 inquiry for a shiny app that if I build it, they're going to pay me $50,000. And you know what? I don't know if I'm going to do it yet or not, but that's the power. That's the power, guys. Okay. I'm sorry. I get excited about this stuff. I get fired up. Dinu asks, do you have corresponding version in Python? Most of my organization is aligned with the Pi environment. I have one Python course, which is kind of like the equivalent of this course here, which maybe get you like an analyst position. But here's the thing. My entire R system is created already. And I get that your entire organization is aligned with Python, but here's what I'm thinking. Maybe you take these courses. Number one, you can learn how to convert them to Python. It took me 3 years to develop this. It's going to take me probably at least another 2 years to develop Python. But this is available right now. And you can get a job at a new company. In fact, you're probably making $150K a year, which may or may not be what you're making right now. But if it's not, we can get you that job. Just got to learn R. All right. Bayesian asks, Bayesian or in general statistics requires an understanding of the domain you want to model and modeling any system that requires an understanding of the assumptions prior to modeling the system. Have you thought of this when creating the Bayesian course? So this is an excellent question. So what I tried to do was to be able to model these 2 offers, which is like an experiment, if you think about it. So you're just trying to understand, it's sort of like an A/B test, but it's more complex because some customers naturally will purchase a lot more and other customers will naturally purchase a lot less. So if you just do like a t-test, you're doing a disrespect to the actual system at play, because those customers have features like age that may impact, younger customers may buy more shoes, older customers may buy less shoes or more shoes, depending on what types of shoes you're offering. And they also have other types of important aspects, like how much business they've done with the company previously prior to this experiment. And then we send certain customers different offers, and we see what offers they go with. And then we see how that impacts the number of orders that we get. So we saw in this that our offer 1 outperformed our offer 0, which is our normal offer, by 0.2 on the coefficient. So it has a positive relationship. And we did really investigate that through this analysis. So I'd like to think I did a pretty decent job at understanding the domain, but there's always more things that you can do. And I agree with you. You really need to understand the domain before you jump into analyzing the customers. But I think we respected it in this. Aline asks, hi, Matt. In any of your tracks, do you teach Bayesian and mixed models? So we're going to be putting these in Learning Labs Pro, and here's why. So my core curriculum is designed to give you the essential things that are going to take you from A to Z in terms of like what's actually going to be the most important. And it's based off of what I've been asked to train elite data science companies like S&P Global, Apple, Microsoft, and so on. And these are the core things, the elements that were really important, like shiny web apps, like time series forecasting, like advanced data science using H2O AutoML, and the foundations like the tidyverse and so on. So I teach those in my core curriculum, but external to that, I don't want to take 6 months to release a course. So I do these learning labs as kind of like small little bites of how to learn Bayesian. So we're going to do what's called a learning lab series, which will be a sequence of like 2 or 3 or 4 labs Our biggest sequences are like time series, advanced time series, which is like 8 labs. But like most sequences or series end up being like 3 or 4 labs. So expect 3 or 4 labs on Bayesian. We're also going to hit Python Bayesian. We're also going to hit mixed models, GAMs, how to replicate GAMs in Bayesian, and how to do all the like really important things you need to know if you want to take the core stuff that you learn in the R track and extend it to Bayesian. So hopefully that makes sense, Aline. I hope that makes sense to you. Okay. Didier asks, I would like to know an idea of the ratio of time between Bayesian and frequentist approaches. So if you're talking about the ratio of time between like how long it takes to train a model, so Bayesian is going to be probably around like 2,000 to 4,000 times longer. The reason is because it has to, well, it uses this program called Stan, and you have to set Stan up and it compiles it. Stan does actually run pretty fast, but the amount of iterations that you're doing these resampling techniques is, like 2,000 iterations per chain. You normally do like 4 chains. So that's 8,000 iterations. So that's like 8,000 models that you have to make predictions on. So it will take a little bit more time. For this analysis, it took me like 30 seconds to run it when I didn't have Zoom on. Now, Zoom takes computer resources, so it'll take a lot longer. And that's why I didn't demo. That's why I didn't like actually run it. But I just stored the model before the analysis. I didn't want to have you guys sit for like 2 or 3 minutes while it ran. But good question, Didier. Sazmito asks, how does the course, is it more valuable than other courses online or available? I'm already applying myself to 2 courses already, going to lose my job soon, so trying to give it my all. So what I would say, and I first off, I really respect you being honest and letting us know that you may be losing your job soon. I never want to see somebody lose their job. What I do want to see you do is I want to see you stop doing what you're doing right now, which may or may not be getting you results. It's probably not getting results. So if you join this program, I highly recommend that my 5-course R track be the only thing that you're taking for the next 6 months. It's not for somebody just looking to dip their toes in. This is a serious commitment. It's going to be something that you need to put your effort and energy focused on. But if you do this, just like an MBA would, or just like a college degree would, it will give you the skills that you actually need in 1/8 of the time. And that's my goal. So a 4 years college degree, we can press that into 6 months of learning by cutting out all of the fluff, streamlining it, and giving you basically the essential insights and tools and technologies. And you see how to do what I used to do when I was consulting, when I was working at companies previously, when I was training elite data science teams. I packaged all that information and I've put it into the system here. And that's what the system does. So that's why I think you should stop doing the other courses and you should commit to the R track, because it will get you the results in 6 months or less. Could be faster if you can put in more time and if you can, slam through it. Okay. Dinu asks, looks like others have the same question if the Python on the track. Look, guys, I appreciate the questions on the Python track. It's just not available yet. That's the bottom line. It's going to take 2+ years. If you want to wait 2 years to get 5 Python courses, by all means. But you know what's going to happen? Data science is going to pass you up. Right now, companies need data science. And I'm telling you, there's 8,000 jobs out there right now with the R programming language. And when you're learning Python, guess what? There's 32 times more competition than there is for R, because there's 32 times more people who know Python already that you're competing against to get these Python jobs. So my recommendation is learn R. I mean, it's a numbers thing. I'm a data person, and I got to be honest, you're in a better position if you learn R right now than you are if you start learning Python, because there's 32 times more people and there's only 3 times more jobs. You see what I'm saying from a numbers standpoint? So R makes more sense to me. It's a hidden secret that not many people know, because all they see is data science jobs. They want Python. Well, if you search R data science jobs, You might find some R jobs, and you know what? They pay even more than Python jobs. You hear that? I'll say it louder. They pay even more than Python jobs. So the system's right here, guys. All right. Bayesian, anonymous asks, Bayesian prediction intervals are about the distribution of the expected value and not the noise variance. How do you communicate this in your course? So I mean, you just saw the analysis that I did right now. I mean, I tried to basically say that as with, as many words or as few words as possible, but basically it's the MCMC. You're sampling and you're constantly predicting values for these parameters. Those parameters help give you a distribution for your response or your predictions. So it's really cool. I showed you the image, guys. I showed you the image of how when the variance increases, the spread actually increases. When the variance decreases, the spread actually decreases. So I tried to explain that as well as possible. I'm an application guy, so I do it with graphs. I do it with like, hey, this is the results we got. This is what it looks like on a graph. If you want theory, I would Google, I would check out, honestly, Josh Starmer's YouTube, StatQuest YouTube. Amazing. He's the best theory guy on the planet. If you want theory, check out his free YouTube channel. I love plugins, Josh, because he's absolutely fantastic. But if you saw what I did with the applied analysis here, that's my area of expertise. I teach people how to apply data science to real problems, and that's what you got to see here. And hopefully, I explained it well enough. But that's my forte. Okay, let's see. Dinu asks, are you sharing the Python cheat sheet? No, I'm just going to share with you guys the R cheat sheet. I hope that's all right. That's more fitting. I didn't have the Python cheat sheet prepared. Sesmito asks, how does the MCMC differ from bootstrapping? So MCMC is run with an algorithm called STAN, where they actually basically sample all of these. They take what's called draws, and it may be just a terminology thing. Like bootstrapping, you're going to be sampling, I think, is that with replacement, and the draws I may or may be with replacement. I can't remember right now. But anyways, it's a sampling technique. That's all we need to really understand. And what it does is it helps us produce kind of like the more accurate distributions. And that's what, like, I think with bootstrapping, obviously it doesn't use STAN most times, I would think. And it's probably going to run a little bit slower. That's kind of the advantage of STAN. You get the MCMC, which is like designed for this sampling technique. Okay, Carlo asks, how can I perform probabilistic forecasting with time series? We're going to talk about that in the Bayesian series. So in probably 2 labs, we're going to talk about time series, and we can do what's called probabilistic forecasting, and we will most certainly cover that. There's a lot of algorithms out there to help with that. Jamie asks, yes, thanks, Matt. So would that reduce collinearity too? Collinearity is more of a function of making sure that you don't have like predictors that have kind of like what we call multi-collinear, or they basically they have the same variance. So you would want to reduce those before you do the Bayesian approach. Bayesian, I don't believe, helps with multi-collinearity unless you use like a different algorithm than what we use. Okay. Robert asks, if you sign up for the R-Track offer, do you also get the discount for Labs Pro? Yes, you do. So as soon as you type in your information here, it's going to go to another page. It's going to say, hey, do you want Learning Labs Pro? If so, we have an offer, a special offer for you, and it's going to give you that special offer. So once you sign up here, that'll be the next step, and you can either take it or leave it, but it's a pretty fantastic offer. So, Jamie asked about homoscedasticity. Okay, yes. So Bayesian will help you, and we're going to see this in the next lesson. So when we have distributions that are skewed, and when we have distributions that change variance over time, that is what Bayesian is amazing for, super, super amazing. And I'm so pumped about it. I wish I knew it like back in like 2016 when I was doing a lot of this stuff. But like what heteroscedasticity is when your time series start to vary more and more and more, kind of like an exponential pattern. Bayesian calculates the probabilities based on how much that spread is spreading. And it's amazing. It's insane. So we'll see, Jamie, tune in to the next labs in the sequence, because we're also going to be doing some like cool stuff with that. Diraj asks, any plans for a Bayesian modeling course? So my plan right now is just to do the learning labs. We'll see how much interest we see. I know we did have, like 700 people or 800 people attend this one. So if there's a lot of interest and they keep coming back, then maybe I will turn it into a course. Ileana asks, would you recommend this for a VP in business as a learning base to lead teams, or is it too technical? So it depends what your goals are. So if you really want to dive into, like when I was a VP and director, this was really important to me, because I was doing more instead of leading team. Well, I was leading teams. I had a 60-person team underneath me, but what I was really doing was I was providing my CEO insights. And that's where the tools that I teach here, it was, think of it like an MBA on steroids with like, a machine gun, right? That is what you get in these 5 courses that allows you to like do amazing data science. So I hope that makes sense, Ileana. I wouldn't do it to like help you manage teams. I would do it if you want to provide your organization insights, and this will give you like a tool set that no other executive has in your company. I know, because I was getting promotion after promotion. I got 3 promotions in a year just by like feeding my CEO amazing reports and analyses that nobody else in the company could do. All right. Anonymous asks, we aren't getting the link. Can you paste it in the chat? Here, I'll put the link in again. I'm just going to put the, whoops. Yeah, we'll paste that into the chat. So if you guys put it in the chat, you guys can check out, I just put the link in the chat. If you guys want to check it out, it'll take you to this page, and then it's very simple. Just put your information in here. Okay, let's see. Whew, we're getting a lot of questions here. Jason asked, not sure if I missed this. If I sign up for these courses, do they expire, or is there a lifetime subscription? So if you sign up for the RTrack, you will get a lifetime membership to the courses. You get all of these for life. So if something happens, or you're not going to lose them. When you pay when you get the special offer of $19,999, that's going to give you access to all of these courses, and you're going to have them for life. So no matter, if you want to refer back to them, or as I update the courses, you get the changes, those are going to be available to you. So the Learning Lab Pro subscription, though, if you take a subscription, there is also a lifetime membership. So you can upgrade to a lifetime membership for LL Pro, and that will give you LL Pro for life as well. So pretty fantastic. We've got a lot of options for you. But good question, Jason. Christian asks, I see a lot of buzz around AutoML and other automated systems. How can we shield ourselves and protect our jobs from stuff like that? Okay. So AutoML is not a hindrance, because AutoML is actually, I teach AutoML in this course, H2O AutoML, and it's actually a massive productivity enhancer. Okay. So if you follow me, the real problem, though, that AutoML does not address is, how do you clean data? How do you merge data? How do you access different data sources? And how do you get data externally from like websites and APIs? How do you build a system to process that data? And then how do you format it in the right way, so that way your machine learning algorithm can actually use it? You see all of these automated solutions like Data Robot, or, insert the name. I mean, there's like thousands of them now. Like, all they do is they solve the one little problem, which is machine learning. But and that's like the tip of the iceberg. If you ever seen like a tip of an iceberg, and then the problem isn't the iceberg, the tip of the iceberg. The problem is the whole thing underneath it, right? That's what you got to worry about. And that's your data wrangling, data cleaning, your formatting, pre-processing, building APIs, moving it into production, and so on. So those automated machine learning tools only kind of really address the one part of the problem, the smallest piece, which is machine learning. Okay. Oscar asks, hi, thanks for the tutorial. Could we please explain the prediction plot? And what is the major difference between linear regression and Bayesian regression? All right, Oscar, that's going to take a long time to go back over. That's what the purpose of the training was for. So if you want, I suggest joining Learning Labs Pro if you want the recording, and you can go back through it on your leisure. Alexi asks, do you cover XGBoost in your course? Yes, I cover XGBoost in this course, and H2O AutoML also integrates XGBoost. And in my time series course, one of the main time series algorithms that we use is XGBoost. We also use ARIMA Boost, and we use Profit Boost, which are all based on XGBoost. So each of these three courses covers a little bit of XGBoost. This is more like the actual algorithm and the hyperparameters. This course is more like as part of an automated solution, which makes ensembles. And this course is using it for a specific use case, which is time series. Okay. Hopefully that makes sense, Alexi. Okay. Yves asks, I cannot understand. I cannot your answers, Matt. Sorry. Yves. William Zhu asks, is the AWS course enough to start a web-based service or to broader audiences for finance and data-related services? What else do I need to learn? So this course here will teach you how to build a Shiny app, how to make it so that way it can handle multiple users. So it has to have a Mongo database on the back end. And then how do you, like in a data science team, for example, or a business team, you're gonna have multiple users. And then how do you put it onto AWS so you can have others access it in the cloud on AWS servers? And we use Docker and GitHub for that. Now, if you want to start a service for broader audiences in the finance and data related services, so it depends what you mean there. It's not for like having an app that has like 200,000 users. It's for mainly kind of bridging the gap between what you build for your organizations and having smaller teams of like 10 or 5 people be able to use these apps that you build and get business insights from them. Or you can also do, I've seen it on the other end, customer facing, like if you use a service like RStudio Connect, this basically gives you the foundation for that. Okay. All right. Will you share the art cheat sheet? Yes, I'm going to share that in just a minute. I just want to make sure I get through the rest of these questions. Let's see. Will you make a communication course for technical speaking to non-technicals? I regularly meet with department heads, and I find unless you're able to communicate effectively, they won't act on the data. Would you make a course or another lecture on communicating to stakeholders? So and P.S. You love the Shiny course. You're already 60% done. And this is from Patrick. Oh, thank you so much, Patrick. I'm really appreciative of it. So the communication side of it, I'm actually working on something right now, which is how to get a data science job. It's a newer course, but I'll have more information coming out on that. But I actually address a lot of this stuff in there in that particular course. Okay. Anonymous asks, if I'm not familiar with time series, is it a good idea to enroll in data science? Well, if you enroll in this program, I will teach you time series. I'm actually an expert in time series. I've built several like 10-hour packages on time series, and I will continue to, and I teach you the time series packages I build. One of them is called Model Time, which is fantastic. In fact, we're in the M6 financial forecasting competition right now, and we're top 30 out of 800 teams. So we're doing pretty good with Model Time. So yes, I would enroll with the courses, and I'll teach you everything you need to know in order to become a time series expert for your organization. All right. Paul asks, cheat sheet, please. Okay. Sorry, Paul. We're gonna get to it here in a minute, but please be respectful. We need to get through these questions. Moavu asks, are you planning a sale on the Learning Labs Pro Easter sale? There may be some sales coming up. I do not know. I have to talk with our marketing people, but I think the best option right now for everybody is to take this offer right now. We will never go below this, $19.99.99. There is never going to be a sale that goes below that. I can tell you that right now. Anonymous asks, what are the prerequisites for this course? without the level of expertise is required going into the course with respect to knowledge and advanced topics? Excellent question, Anonymous. So this course is designed to take anybody with like a background with Excel or business to be able to get it up and running. I teach you everything in the foundations course that you need to know to get started. In fact, that's exactly why I built this foundational course, because I launched this course first and I had people saying, hey, this was, you know, a great course, but like, I'm just not at the skill level I need to be quite yet. So I made this course, and this course gets everybody from 0 to like, you know, 6, and then 6 to 9, and then 9 to 10, and then 10 to 12, 11, 15, you know, getting you like super powerful. All right. So that's kind of how it works, but you don't have any prerequisites if you start taking this course first. Okay, great question. Mancy asks, how can we use Bayesian approach for confirmatory factor analysis? I don't know what confirmatory factor analysis is, so I don't know how to do that. I apologize, Mancy. I will look into it though. Okay. Sasmito asks, how does math that are discussed and used to solve problems in data science job, is it doing equations on a chalkboard or more of an algorithm? So I teach the whole process of how to solve data science for business problems. It actually took me like 5 years to like really become comfortable with it, right? So there's two key aspects. You need to understand how to tackle business problems, which I teach in this course here, and I use a framework that I used that I used while I was consulting for companies. And I built this framework because I had a bunch of problems with some of these consulting jobs with these companies. And they were coming back and like saying like, oh, I didn't do, you know, they were getting mad at me, and I had to figure out why. And I figured, oh, it's because we didn't have all the stakeholders involved. And it's because we didn't like fully understand the problem, and we didn't get this part of the group involved. And like, oh, okay, now we're not ready to move into machine learning because we don't have this yet. So that framework I cover in this part of the course. And that's really was a powerful like aha moment for me when I first understood, okay, I need to have like, there's a repeatable framework you can follow for like 90% of business problems. And that's what I cover in this course. So that's how you have to do it. It's not really like math on chalkboards. It's more like, hey, do you have a process to solve the problem that you're trying to tackle? All right, next, Anonymous asks, I think people have allocated 1.5 hours for this really informative seminar. They're having to drop off without the cheat sheet. I apologize. I know that's unfortunate, and I will get to the cheat sheet just here in a minute, but we really need to be patient, guys. We have a lot of questions here, and we want to make sure that I get through them all. All right, if I am in the healthcare sector, do the skills still apply? Yes, absolutely. In fact, this is sector agnostic. I teach mainly because most companies have customers and most companies have employees. So those are the types of things that I teach. Most companies have websites. So I teach how to deal with website data, how to deal with employee data, how to deal with customer data. But any type of, you know, what I'm teaching are foundational skills that can literally be applied to IoT, manufacturing, healthcare, pharmaceuticals, you name it. I've had student success stories in every single industry that's out there. And it's amazing because I never thought that one system could cover everything like this system does. And it works so well. I mean, you saw the testimonials, Northwestern Mutual, financial company. We saw Microsoft, that's a tech company. We saw JP Morgan, another financial company. We saw, what else? MoneyView, financial company. So a lot of financial companies. We have predominantly, I think 25% of our people are actually marketing. About 15% are financial, but like the other, like literally 65% of people are, you name it, manufacturing, IoT, healthcare, pharmaceuticals, you know, everything. All right. So it will work for you. I promise you that. Wycliffe asks, everything you post in the chat is not visible to us. Kindly check if you set to everyone or host panelists alone. Let's see. Oh, everyone. Oh, shoot. I apologize. There, I just put the link in the chat. Can you guys see it now? I apologize. I did have it on. I didn't have it flipped over to everyone. Can you guys see it now? All right. All right. Okay. I apologize. Okay. Sorry about that, guys. Here. What else did I put in the chat? Okay. Yes, I do. Yes, I do. Okay. All right. Does this promotion link accept split payments by any chance? I don't think we have split payments set up, guys. So I apologize about that. Okay. So let's see here. Okay. All right. All right. So continuing on, we're going to get to the cheat sheet in just a second. How do I access the discount for LL Pro? So Mwabu, we'll talk about that here later. Let's see. Olumide, can I have a link to view this webinar again? Learning Labs Pro. I'm going to put the link for the courses one more time in there. I can't believe I did that. What a bonehead move. Please share the cheat sheet and the offer link. Okay. Seems like does the R track contain videos where you talk through concepts like you did today? The R track, Stuart, the R track goes into even more depth than what you see here. So we have literally 1,000 hours of video. You're going to learn so in depth, line by line. I do line by line coding in there. So I didn't do line by line. You just saw me like run sequences, sections of code. I actually type out every single letter of a function. I show you where to get the help documentation. I show you what that function does. I show you why I'm using it. I talk through the specific examples. So like you are literally getting the most premium courses that you can get. And this is the best experience for learning data science, bar none. Okay. All right. We are going to go next to the cheat sheet. Okay. So if you guys are ready, let's do the cheat sheet. So let me do this. All right, let's do this. Okay, and again, real quick, before I do the cheat sheet, I want to give you guys this link one more time. Copy the link address for everyone that's stuck around here. If you want to enroll, you can enroll in the R track now. And $19.99. And then now here is the cheat sheet. So let's check out the cheat sheet, guys. I just put the link in the chat and I'm going to click it and I'm going to download it. Here's how it works. All right. So I just pulled up the cheat sheet. Should look something like this. You're going to have links here. If you guys can see these, you got links to, well, there's 3 pages. The first page is the basic workflow for data science. The second page is the shiny web applications, the shiny verse. And then the third page is the special topics. Again, this is super important if you want to work in time series, financial analysis, text analysis, network analysis, geospatial, machine learning, speed and scale, interoperability, working with Python, and more. So how it works, each one of these links to a website, and this is the documentation. So it's a cheat sheet that kind of links to all of the different important things that are out there. But wait, it gets better. It's a cheat sheet that also links to cheat sheets. So I just click the CS, and now what I'm opening up, which just opened up here on another screen, is a cheat sheet for ggplot2. So these are all the important functions that you need to know when you dive in. Okay, so hopefully this will help you. I think this combined with the with the R track system, which is right here, will help you learn data science. I'll put the link one more time in the chat. And please, guys, please, 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 let me know if you have any more questions. I can answer them right now. All right. Yes, Allison, it's a lovely free gift for your Wednesday. Nice. You got it. You got it, guys. Let me know if you guys have any questions. If not, we're going to shut this thing down. All right. I will put the link in the chat one more time. Thank you guys and enjoy. And I will see a bunch of you in the art track. All right. I'll catch you guys later. See ya. Bye-bye.